Bismillahirrahmanirrahim. Hello students. Today I'm going to explain the last experiment for this course, which is DC braking of a three-phase induction motor. Actually, after explaining this experiment, you will be able to understand the principle of DC braking three-phase induction motor, and you are going to be able to construct a magnetic control circuit incorporating DC braking, and also you can evaluate the braking action using different values of resistance to limit the DC current. The DC current braking method, it is a good method to bring an induction motor to a quick stop. So this is the advantage of direct current braking. So we need to stop the motor or the rotation of the motor very quickly. If the state of induction motor is excited by direct current, what will happen? A DC flux is set up in the motor. So here it can be set up as like a set of stationary magnetic poles will be developed. The poles are equal in number to those in normal revolving field, and their magnetic field are kept by rotor conductors. Voltages are generated in the rotor conductor, causing current to flow in the squirrel cage. This current, in conjunction with the DC flux, develop torque, which is opposite to torque driving the motor. So by applying this kind of method, direct current injected to the motor, if the direct current is injected to the motor, we will be having DC flux. This DC flux will develop torque which is opposite to the torque driving motor, the main torque which drive the motor. When they are opposite to each other, the motor will be stopped very quickly. So that's also the mechanical energy of rotation will be converted to heat. As you know, I square R dissipated on the rotor. So during the period of convergence, the motor continued to slow down until we got zero speed. So the torque becomes zero. What is the advantage of DC braking over the plugging method? We should recall the plugging method. What does it mean? A plugging method, it is to reverse the direction of the motor while the motor is running in forward. Here, DC braking, since we are having like opposite torque to the main driving torque, is it going to reverse the direction of the motor or not? One of the advantages of DC braking over the plugging method, the motor will not start to rotate in the opposite direction. So this is the main advantage of DC braking. A control circuit that's provided for dynamic braking, in addition to its other function, is generally equipped with rectifier. So the DC current can be generated from the rectifier, which the AC will be converted to DC using the rectifier. But since we are using a low voltage station and we have already got the DC source, so such a rectifier is not needed anymore. So the direct current needs to be adjusted. Why we need to adjust it? Because we don't want to damage the motor. So the direct current needs to be adjusted to a value of 6 to 8 times the rated motor current in order to achieve a quick stop. In order to adjust this value of direct current, what are we going to do? We are going to connect a resistor in series with the DC source in order to limit the DC current injection. We will see in the next slides. So direct current can be supplied to the three-phase winding by a pair of set of terminals. So for example, we have three terminals. So we can inject the DC current through terminal 1 and terminal 2 and leave terminal 3 open. Here is the circuit, the main circuit, when we are utilizing the rectifier here. So if we are going to apply this experiment with having only AC source, okay, so we need to have a rectifier to convert AC to DC in order to be injected to the motor here. But since we are using low voltage station, as I have mentioned before, so the DC source is available here, so we don't need to connect a rectifier along with the AC source. So here the DC source. Let us explain the operational step of this circuit. First of all, closing circuit breaker here. So we can have a voltage for the control circuit. So when the start push button is depressed here, what will happen? M coil will be energized. M normally open contact in the control circuit will be closed for holding. Then all M contacts, open contacts in the power circuit will be closed, motor will run. Here also we are having M contacts, okay, but they are normally closed. When this M coil is energized, this one should be open. These two should be open. Why they should be open? Also to prevent the DC current to be injected to the motor. So this one is like to interlocking. So we have used this one for the double the safety, for example, because we are also here having DB contacts are open. So also here will be open once M coil is energized. Okay, if we want to break the motor, so for quick stop, what are we going to do? We will depress brake push button here. When this one is depressed, both coils DB and TR will be energized. When they are energized, this one will be closed for holding. This one will be open. When this contacts open, what will happen here, guys? M coil will be de-energized. So the shaft is now freely to rotate. What will happen here when this one energized? Okay, when it is de-energized, so here will become closed. Okay, then TB here going to be closed to inject the current to the motor, DC current to the motor, then will produce DC flux and develop DC torque, which is opposite to the main torque. Then the motor will be stopped quickly. Don't forget that when these two DB and TR are energized, this will return to be open, because this one is de-energized. After time, what will happen here? As you can see here, there is a TDO. So after time, what we have to do? This one, TDO, should open to de-energize both coils. So the main purpose is to de-energize DB coil. Why is that? Because we do once the motor stop, we don't have to continuous injecting DC current, because if we are going to continue injecting the DC current and the motor is already stopped, it might damage the motor. So we have to set the time. Once the motor stop, the injection of DC current should be stopped too. Okay guys, so we have finished from the explanation, but we have here resistance that's connected in DC source. What is the purpose of this resistance? The purpose of this resistance is to limit the DC current. By limiting this DC current, we can decide the time of stopping the motor. In this experiment, different values of resistance should be applied to see how quick that how the quick can stop the motor by using different resistance value. So this is the whole explanation of this circuit. And one thing needs to be take care of. What will happen if the motor is running, okay, and we depress the stop push button? If we depress the stop push button without depressing the brake push button, the motor will stop, but it will not stop in short time. It will take long time, because the shaft will continue to rotate freely. So the braking method, it is a quick method to stop the motor. Here are the operational steps of the experiment. I hope you got the full information about this experiment, and we are going to post assessment regarding to this experiment. Thank you guys, and wish you all the best.